You should now be in a position where you've got MySQL installed and you're ready to start learning about some queries. And before we can learn about the different types of queries, we're actually going to need at least one table. In order to create a table, believe it or not, we're going to need a query. So we're going to need a create query, a create table query in order to create a first table. But before we do that, let's just have a look at the one which we've already looked at in an earlier lesson, which I've already created, and I'll trash this at the end of the lesson, or I'll trash this shortly so we can start from fresh. Just to have a look at the anatomy of a MySQL table, or any SQL table really. They all look fairly similar. And so here, as you can see, as we've previously discussed, you have a load of rows and a bunch of columns, and it's actually the columns that we're going to be interested in here. How do we create a column for ID, name, age, department, and salary? They all hold different types of data, and so when we go to create these columns in the table, we need to tell MySQL what kind of data we expect them to hold, and also what size, how many characters, for example, should a name column be able to hold. And so I'm in Table Plus. You might be using something else, but at the bottom here, very small in the bottom left hand corner, I can look at the data, which is what we're looking at here, the data view, or we can look at the structure view. And this will tell you more about each of those columns, what kind of data they hold, and also things regarding things like keys, which I don't want to get into too much at the moment, but which we will definitely be covering a lot of. So here, let's just talk about these one by one. So ID, the column is ID. The data type which is holding is an integer, so just normal whole numbers to you and me. The next thing you see which has a value is nullable. Can this column, can any of the rows have a null value for the ID? And the answer is no. And here where it says extra, it's saying auto increment. So this is actually an auto incrementing primary key. This is the main identifying column for this table. We'll touch on this later on, but in order to like relate columns, or to sort of the quickest and easiest way to pin down a particular record in a SQL database is using its primary key, and so it's also known as an index. And here we'll briefly just have a look at this. It's like I say, the ID is an index, and indexes, they just make records easier to find and to look up. Think of an index in a book. Indexes in databases and tables work in pretty much the same way. They make things easier to look up, and so therefore make your queries faster. The index name here is primary, so that means it is the primary key for this table. Okay, so next we have name, and we're saying this is a varchar, so this is like alphanumeric characters. That's what varchar means, and what the 100 in parentheses means 100 characters. So that is the limit of what it will hold. It will hold up to 100 characters. The collation and character set. So this is just telling you what kind of characters this can hold. So here we're saying UTF-8 MB4 is nullable. We've actually said that name can be nullable, and all the other fields have been set to nullable for this particular table, and only the ID actually needs to hold a value. Okay, next we have age. Again, this is an integer, and we've said it is nullable, so it can have a null value. Department, again, this is a varchar, will hold 100 characters, so like the name of a department. And you'll notice it is really mainly for the varchars where the character set is important. And so depending on where you are in the world or whatever you're building, you'll probably use different character sets. For example, if you're working in Chinese or something, you'll use a different character set than what you would if you were working in Europe. And salary will be an integer. So just one thing on salaries and things like that, if you're dealing with money values, you'll often see instead of using floats, you will use like integers, and so it will go down to include cents in the value. So say for example $1 or £1, instead of having a value of 1, you would have a value of 100, and it just makes working with monetary values a little bit easier than trying to use floats, especially when it comes to like converting from one currency to another. Okay, so there's a brief anatomy of a table and some of the different data types you can have. Now let's go ahead and create this table. I'll show you the SQL that we need to create it. Now the first thing I'm going to do in order to start from scratch is to actually drop that table. And so you can drop a table using drop, and then it will be table, and then just the name of the table. So in this case it's employees. I'm going to highlight all of that using Shift, Command and then left. That will highlight it all, and you can see here if I do Command and Enter, it says it will run current. So anything which is highlighted will get run if I hold Command and Enter on Mac. On Windows, I imagine that will be Control and Enter. Hit that, and then if I hit Command and R to refresh, you can see that the employees table has gone. So we now have a blank slate, and I can go and create that table from fresh. So here is the create query for creating a table. So we say create table, and then we give it a name. The name in this case is going to be employees. And then what we need is an opening parentheses in which we will wrap all the columns which are going to exist in this table. So we have an opening parentheses, the columns and the column definitions, which we'll talk about in a moment, followed by a closing parentheses and then a semicolon, which is used to separate your queries from each other, and it's very important. So the first one, here is how we do the ID. So first thing you need to do is provide a name followed by the data type. Here we're saying that this will be an auto incrementing value, so you won't need to provide a value when you create an employee record for the ID. It will just auto increment. So if the last record you entered was 66, the next record you will enter will be 67. And then we're also saying that this is the primary key for the table, so the key which will be used as the main identifier for an employee. Next we have name. So ignore the fact that it's highlighted in a different color here. I think it's because maybe name is like a word which is also used in SQL, but just ignore that. So the name is the name of the column, and then we are saying we want this to be a varchar with a maximum of 100 characters. Next, we're going to call the next column age. That will hold integers. After that, department. This again will be varchar. I'm going to say 100 characters for that. And then salary, which will be an integer. So once you've defined all your columns, and this is a very simple and basic definition as our first one, we will do more complex ones later on. But once you've done that, what I'm going to do is just highlight it all. But because there's only one query in here, I don't think I actually needed to do that. But I'm going to say run current, Command and Enter. Hit refresh, and then as you can see, I've now recreated my employees table. Has no records in it. When you first create a table, it's just created with no records inside of it. But if you look at the structure, again, we have these same details as what we looked at before. So is nullable. You'll notice some of these things were quite implicit, right? We didn't say nullable or not nullable. For a column which is an auto-incrementing primary key, then MySQL will know to make that as not nullable. It has to have a value. If we wanted the others to be not nullable, what we would have actually had to do would have been to tack on not null. In fact, we'll do that for some of these. So here I'm going to say not null. But first I'll actually drop the table and we'll start again. So drop table employees, and highlight that, Command and Enter, refresh. So you can see the table is gone, and here I'm going to make all of these except salary, in fact, not nullable. And so that means you won't be able to enter values or create employees which have a null value for department, age, name, or ID, which is done implicitly. Let's go and run this again. Refresh. The employees table is back. Let's look at the structure. And so here you can say where it's saying is nullable, we now have no for all of these. So only the salary can hold a null value. Okay, so hopefully you followed along and you've managed to create the employees table there. Now that you've done that, hopefully you're confident enough to be able to create a table yourself. And so that's going to be the challenge for this one. I'm going to try and set challenges in most of these lessons. So here what I want you to do is try to create a products table. It's going to have 4 fields, and I'll give you the details of those fields. So the first one, much the same as the employees. In fact, you can just copy what we did for that one if you want. So we want an auto-incrementing integer primary key. The next one will be a field called name, so the name of the product, 255 characters, not null, so we can't have null values for that. Price will be an integer, not null. And the little wildcard here, we're going to have a manufacture date. And this is going to be a type which we didn't include in the last one. And so a little bit of experimentation for you. But what we want is a date type, and I believe you can do it using that type there. So date uppercase like so. So if you think you're up to it and you fancy the challenge, I highly recommend you have a go at all the challenges. That is how this stuff will stick in your brain for life. So pause me now, give it a go. Okay, so here is my solution. So what we want again is create table followed by the table name, which is products, opening and closing parentheses, and then put your semicolon on the end. So what I'll typically do actually is I will do this bit first, make sure I've got all the structure right, and then start to add the columns one by one. Notice there is also a comma after each line except the second one. If you don't have that comma in there, then you will get like a syntax error. MySQL will explode on you, and you may get quite a few errors at the first when you first write your first SQL. And I must admit, MySQL, the errors aren't as good as something like PHP. They can sometimes feel a little bit cryptic. So just be careful. If you do get any errors, just have a look at my code and copy that into yours rather than waste a lot of time trying to figure out what's going wrong, especially when you're new to MySQL. All right, product ID. This should have actually just been ID. Hope you spotted that deliberate mistake there. So we're saying integer. This will be auto-incrementing, and it will be the primary key for this table. Name, this will be a varchar with a maximum of 255 characters. And then we're saying price will be an integer, and then manufacture date will be a date. And so if you remember what we said, these ones are going to be not null, and only the manufacture date can be nullable. So we don't need to put not null for a primary key. That is done implicitly. But what we do need to do is make these not null. So name and price will be not null. So notice this is 2 words, not 1 word, which is one of the quirks of SQL. Some of the little commands and keywords come in 2 parts. Okay, and I think that should be good. We don't need to make manufacture date not nullable. That can hold no value, because sometimes for a product you might not always have that kind of detail. All right, let's go and highlight all of this. I'm going to hit Command and Enter. I don't have any errors. You'll see in very small writing there, it says query 1, okay, 0 rows affected. Basically what that means is nothing went wrong. So we should, when we hit refresh, Command R, see a products table. And if we look at the structure and just have a quick glance and check it out, integer auto incrementing not nullable, name varchar 255, UTF-8 MB4. So because I didn't provide a character set and collation, this is what it's using by default. So maybe in a later lesson we'll actually set our own character sets and collation just to see what that looks like when we do it that way. Is nullable, no. Price, integer, not nullable. Manufacture date is a date type, so that's the first time we've used that type, and we've said that that is nullable. Okay, cool. So what we've done there is we've created an employees table, and hopefully you've had a go at creating your own products table. And so what we want to do in the next one is start adding, deleting, and updating records in these tables. Let's move on. We've seen how to create a table. We know how to create a table with all the different data types for the different columns that we need. So now what we want to do is we want to start adding some data to the table. In order to get data into a database table, we need to do a particular type of query called an insert query. And they look like this. So what we're going to do is we're going to enter a record into our employees table, and the syntax is this: insert into, and then the name of the actual table, in which case ours will be employees, and then you want to list the columns that you want to insert, and so we're going to insert records into name, age, department, and salary. So notice that the ID wasn't there. Because this is an auto incrementing ID, what happens is that MySQL will actually automatically generate that number itself, and it will be just the next incrementing value after each record has been inserted. So if we insert a record, it gets given an ID of 9. When we insert another record, it will get given an ID of 10. And so the IDs, we don't actually provide that information. MySQL works out that information itself. And so after you've specified which columns, notice also that this is in parentheses. We specify which columns we want to enter into inside of parentheses, and then it's the keyword values, and then followed by inside of parentheses here, and you'll notice we have 4 items: name, age, department, salary, and we have a piece of data for each of those columns. So here we're going to insert a single record, and in a moment we're going to have a look at how you can actually just insert multiple records in one go. But let's just insert the one for the time being. One other thing, notice that this ends in a semicolon. So like I said previously, the semicolon is used to differentiate between one query and another. If I was to write another query underneath this, we need to know where one ends and where another one begins. Alright, so I'm going to highlight all of this. I'm going to hit Command and Enter to execute it. I'm being told that we have one row affected and the query went okay. Over to employees, let's have a look at the data. Let's refresh. And so now we have added Bob Smith, age 25, to the marketing department. Okay, and insert queries, they're probably one of the simplest. The most complex queries are going to be select queries, and that's what we're going to be doing a lot of. But for inserts, it really doesn't get much more complex than this. So it's inserts into, name of the table, columns that you want to insert into, and then a value for each of those columns inside of parentheses. So I'm pretty sure that you should be able to do this now. So if I was to give you some details, why don't you have a go at doing this yourself? Okay, so here's what I'd like you to have a go at. I'd like you to write an insert query, much like I just did, except this time use your own details. So for name, use your name. For age, use your age. For department, we'll say IT, and for salary, we'll say 50k. And just before you start though, have a look at where I've used quotes and where I haven't. So for varchars, you'll notice I've used quotes for things like the name and also the department. And for integers, you don't need quotes for those, and so they come without the quotes. And don't forget, you can always just go back and have a look at the actual structure of the table if you need a reminder before you actually write your query. So here we saw that name is varchar, maximum of 100 characters, age is integer, department varchar, salary is integer, and the ID will actually be created for you. So if you think you're up to it, and I highly recommend you have a go at this, just pause me now and give it a go. Okay, so I'll write it from scratch actually. I was going to do a bit of cut and paste there, but I'm going to write the whole thing. So I'll say insert into, the name of the table is employees, then we need parentheses, and we want the names of the tables, or the names of the columns that we're going to insert into. Also notice that the names of the columns aren't wrapped in quotes, so they'll never be wrapped in quotes. You can do them like so. It's only the actual data that you're inserting, for example, into tables which are varchars that require the actual comments. Okay, so it's going to be name, age, department, and then salary, and then it's a keyword values. And so after that, MySQL will be expecting you to provide it with some values. So here will be your name, whatever that is. I'm going to say 28, just made that up. Department will be IT, make sure that's in quotes, and a salary of 50,000. And there's one more thing which I need to do. Can you remember what it is? And that is the semicolon on the end of there. All right, so I'm going to highlight all of that. I'm going to hit Command and Enter. I'm getting a success message down here. Let's go to employees. I want to see the data, and I'm going to refresh. And so now we have a brand new record entered into the employees table. Now, we'd like to have some data to work with when we're doing our select queries. So what I'm going to do here is I'm going to grab some data. I'm just going to insert a load of records. And the way to insert a load of records is, after we've said insert into employees name, age, department, salary, values, you can actually provide multiple values. Except this time, instead of having a semicolon at the end of the line, you'll have a comma, and you'll only have the semicolon after the very last line. And so it should look like this. So notice here, all the same, we're just doing everything the same, except we've got a separate line for each record. It doesn't need to be on a separate line, but they do need to be separated with a comma. And so we're adding a load more records here, and at the very end of the query we add that semicolon. Let's go and highlight this, and then let's hit Command and Enter. 10 rows affected, back to employees, refresh. So now we've got plenty of data in there to work with, and we can start to do some interesting queries in the ones that are coming up. So quick recap: in order to insert records into a database, we need an insert statement, and that looks like this: insert into, followed by the table name, then parentheses, and each of the columns that you want to insert data into. Notice no quotes around those, but they are separated by commas. Then it is the keyword values, followed by more parentheses, and then each piece of data that you want to enter. For like strings, for varchars, you need to put quotes around them. Also, when we come and do dates, you'll need to put some quotes around those as well, but we'll get onto that later on. And then at the very end, you add a semicolon. And if you're inserting more than one record, you separate them all with commas, and at the very end of there, you put a semicolon. So, hope that went okay for you. Run this query here. I'll include it in the lesson so that you've added some extra data to your database, and we can start doing some interesting queries when we do these selects. So by the end of the last one, we've done some insert queries for our database, and we should now have a bunch of records in our database. And so the next thing we're going to have a look at, because I'm sort of doing this in like order of levels of complexity, the next thing we're going to have a look at is actually just updating records in the database, and I'll show you some update queries and how we want to do that. So here is what an update query looks like. And so we start with the update keyword, followed by the table name, and then you're saying basically what do you want to update, what you're trying to do here. So what we want to do here is find the employee John Doe, and we're going to actually give him a pay rise. We're going to set his salary to 55,000, whereas at the moment it is 50,000. And so the query looks like this: set, so another keyword, and then the name of the field, and then the value that you want to give that field. So setting it to 55,000, but then of course we need to make sure that we are setting the value for the right person and not for everyone, because if we didn't include this where clause, what would happen is we'd set the salary as 55,000 for everybody. So what you need to do is make sure you have the where clause to filter down on the exact record or records that you want to update, and make sure that you do that. So when I'm writing these, actually what I'll do is I'll typically do the filter first. So I'll say what I'm updating, make sure that I put the filter in there, and then I'll decide, okay, what am I updating here? So here we're going to say update employees, set salary to 55,000, where name is John Doe. So you can use any of the fields. We could use ID, we could use department, we could use whatever. But in this case, I think it's suitable to use John Doe. If you had more than one John Doe in your database, which is quite possible, you can have more. If you have like a common name, it's very likely that you will have more than one record for that name in the database, and so this probably isn't the best query in those examples. Or for something like this where you're updating someone's salary, it would actually be better to use ID because IDs are unique. But this is our first go at it, and this is a nice simple example, and so this is what we're going to use. So here I'm going to highlight everything and hit Command and Enter. I have one row effected, query OK. Let's refresh this, and so now you can see that John Doe has a salary of 55,000. Alright, so that wasn't too bad, was it? What we'll do is we'll just quickly do one more, then I'll let you have a go at this. So here what we want to do is we're going to move Jane Smith into a new department. So we're going to change the department of Jane Smith to sales. So have a think about how you would do that. Again, starts the same. We're updating the employees table. We are going to set the department to sales, and then of course we only want to do it for Jane Smith, and so we're saying where name is Jane Smith. So she is currently, if I can find her in HR, she's moving to sales. That sounds like a good move to me. Let's go and run this. Let's check out the table, refresh. Jane Smith now works in sales. Okay, one for you to have a go at. If you've created the same inserts as me, if you've got the same data as me, then use this one here. Update the age of Oscar Wilde to 40. If you don't have Oscar Wilde in the database, then just update one of the other records. But yeah, runs in pretty much the same way as the previous two that we've done, so you should have no problems with this. Pause me now and give it a go. Okay, so what we want to do is say update and then the name of the table. Then we are going to set, followed by the name of the column, and then the value. This is age, this is an integer, so we don't need quotes the same way as what we needed for department. We just need the value of 40, and then very important, we don't want to set everyone's age to 40, we just want to set Oscar Wilde's age to 40. So here is where name, and remember when we're referencing columns, the names of columns, we don't put quotes around those. So name equals, and just to make sure that I spell this exactly the same, I'm actually just going to copy that from there. Name equals Oscar Wilde. What's the last thing you do at the end of any SQL query? You put a semicolon. Okay, so let's have a look at Oscar Wilde's current age, 39. So we're now going to go and update that. Select it all, Command and Enter. Back to the employees table, refresh, and Oscar Wilde is now 40 years old. Okay, let's end with one which is a little bit more complex. You can actually include a bit of math inside of your query. So here what we're going to do is we are going to update the salary of everyone in IT. We're going to give them a salary bump of 5,000. How do you think we would do that? The answer is this. So again, we start with update employees. So the same as any update query, it's update followed by the name of the table. And then here we're going to say set salary to the salary, so the current salary plus 5,000, and then again this is for everyone in IT, so we're going to say where department is IT. So let's have a look at the current IT salaries. So we've got one at 50,000 there, one at 75, 50, 58. These should all get a bump of 5,000. Let's go and test that theory. Command Enter, back to employees, refresh. Hurrah! Everyone in IT now has a well-earned pay rise. Alright, there's many mistakes you can make with databases, and mistakes which could get you fired or at least in serious hot water. And one of those mistakes is to update every record when you're only meant to update one. So let's have a look at how we can possibly do that. So I'm just going to copy this, and what we'll say is update salaries. We'll remove the where clause, so that is the key to seriously messing up. Set salary equals, and we're just going to set the salary to 100k. But we've not done a where clause, so what does that mean? It means that everyone is going to have their salary updated to 100k. Let's hit go. 12 rows affected, so when you do an update and you see a lot of rows affected, your heart will probably sink if that's not what you intended to do. Employees, refresh. Oh dear. And what we also don't know is what those values used to be. So you can have like rollbacks and things built into your database, but sometimes you're not working with that sort of level of complexity or attention to detail. And so in which case you've updated everyone's salaries, you don't know what their salaries used to be, and you're in big trouble. Let's now have a look at deletes, and these are another one where the queries are not hard. However, you need to be very careful as to how you write them. You don't want to be deleting records that you don't want to delete, because once they're gone, they're gone. So I need to be very careful with our where clauses, again in the same way as we were with the updates. So here is the syntax. It's two keywords: delete from, then the name of the table. Again, names of tables, names of columns, they don't go in quotes. Where, and then this is a column name, so the name being name equals John Doe. So what we're doing here, we're deleting any employee from the employees table whose name is John Doe. So quick check of the table first. We have a John Doe, just one of those in the table, record number 3. Let's go and run this. Let's go back and refresh. Okay, and John Doe has now left the building. So let's have a go at one yourself. So the sales department is underperforming. We're going to sack everyone. So here what I'd like you to do is delete all employees who work in the sales department. Have a think about how you would do that. So we're not filtering by name this time, we're filtering by department. I'm sure you can do this. Pause me now and give it a go. Okay, so what we want to do is, again, this is going to be delete from employees, and this time it's going to be where, and it is department equals, and then sales. So semicolon on the end. Let's just have a quick check of the table. So we have 1, 2, 3 people working in sales. They're about to lose their jobs. Command and enter. Let's now go and check the table, and all people in sales have gone, so we no longer have a sales department. Alright, let's finish off with something slightly more complex. So the company's now really struggling. Now that they've sacked the sales department, they're actually no longer making any sales. So what the company is going to do is delete all employees with the salary of more than 50,000. So anyone with a salary with more than 50,000 is going to be removed. How would you write this? So delete, and again from employees, and this time it's going to be where salary, and here, because you can use equals, less than, greater than, we're going to say where the salary is greater than 50,000. Semicolon on the end. Let's run this. Let's go back to employees. So in fact it's going to get rid of everyone, because everyone has a salary of 100,000 currently. I never thought about that before I came up with this. Oh well. Refresh. The company is now gone and has 0 employees. So nice end to that one. In the next one, what we're going to do is start looking at select queries, because these are a lot more complex than your updates and your deletes and your inserts, because we're trying to filter down and find specific records which could match like all different groups or certain criteria, or we might just want to get like averages, like average salaries and things like that. So this is where stuff starts to get really interesting. We're now going to have a look at select queries, and this will be a longer section because selects are the harder queries out of insert, delete and update and select, because you can have queries which span multiple tables, you can have queries which try and filter down on little bits of data, aggregates, or sort of using functions, calculate the maximum, and also you can have subselect queries where you perform a query and then you're querying again to get a subset of the original query. So this can get quite complex, but we're going to take baby steps. We're going to build it up piece by piece, because if you try and drop straight into the hard stuff, it'll just mean you don't even understand the easy stuff. So in order to make a start, we ended the last one with no data in our table, so that would not be a good start. So let's just do an insert. You can copy the one which is attached to this lesson, but we're just adding 10 employees to the employees table. So I'm going to hit Command and Enter on that. Just check that that ran okay. So down here it tells me it ran okay, but I always like to have that visual check as well. So refresh on the employees table, and you'll notice that this time when I've inserted them, the ID has started at 13, because even though we've deleted those old records, we're still incrementing from the last record which existed, and that would have been record number 12, and so that is why it's starting at record 13 and not record number 1. Alright, so like I say, let's start really slow and simple with this. These are the things that we're going to try and select for, and so if you think you're up to it, you can work ahead of me on some of these, and they're just going to get incrementally a little bit more complex each time. So the first one is going to be select all data from the employees table. Now we had a lesson earlier where I introduced the anatomy of basic SQL and what queries look like, and so if you remember how we did that there, then why not have a go at this yourself. So you can pause me now and try it if you think you can do it. Here is the solution. So we're going to say select, we want all data, so that would mean all columns. So I'm going to say star, and so that is a wildcard to mean all columns, and then it's a keyword from, and then the name of the table. So I'm going to highlight that, I'm going to run it, and as you can see we have 10 records, all of the records and all of the columns, just as importantly, for the employees table. Alright, so far so good. Next, what we want to do is we want to get a little bit more granular. We don't want all the data, we don't want all the columns, we just want only the name and department columns from the employees table. Again, if you think you know how to do this, pause me now and give it a go. So the way that we do this is we select the columns that we want, but they need to be separated by a comma. So we're going for name and department. So notice no quotes around these because they are the actual column names. These are not data values. So select name, department, then it's from employees. We always end with a semicolon. Let's select that and fire it. Okay, so now you'll see we get back all the records because we didn't filter down for particular individuals. We just filtered by the actual column names that we want. And so as you can see, we have name and department. Okay, so next what we want to do is we're going to do some filtering now. We want to select employees who are in the IT department. So I've not specified which columns here, so we'll just say that we're going to select all columns, but only for the individuals who are in the IT department. Can you think how you would do this? You would use a where clause. So let's give this a go. Select star for all columns, and then we're going to say from employees, but then we need to specify that it's for only the IT department using a where clause. So here we're going to say where, and then it's department equals So single equals, that's one of the quirks of SQL, whereas in programming languages, if you're looking to see if something is the same, you're looking for equality, you'll typically use like a double equals or sometimes a triple equals. But in SQL, whether you're doing an assignment or whether you're checking for equality, you will always use a single equals. All right. So we're checking the IT department. Remember, this was varchar, so we need to wrap it in quotes and we need to end on a semicolon. Let's run this. Okay, and so we have 3 employees in the IT department. Let's just go and check that in the actual table itself. So IT, IT, IT. So 3 records from the IT department, and we selected all fields. Okay, so select employees who are either in sales department or older than 30. So can you think how you might do this? The first bit would start pretty much the same. So we'll be saying select star from employees where department equals sales. So this would change to sales, but then we're actually saying or older than 30. Now there is a keyword called or, so I'm going to start you off on this. I'm going to see if you can actually just have a wild guess at how you might finish it off. So we're going to say where department equals sales and then or, and how do you think you will finish this off? If you think you could have a guess, and I always encourage people to have a guess at things because you sort of thinking ahead of how something might work, and then if you do that and it turns out to be correct, then it really cements the knowledge in your brain. So yeah, have a go at that if you think you're up to it. So we're saying select start from employees, so we're selecting all columns where department is sales or, and so if you want to see if someone's older than 30, let's see what columns we have. We have an age column. So what we're going to say here is or age is greater than, because we have the greater than operator, we have less than, we have equals, and we have not equals. So here we're checking that age is greater than 30. Okay, let's run this. And these are the records we have. So we have some in sales here who are both under the age of 30. And we have another one here from sales who matches both criteria actually. And then we have these records here. So one from HR, that is the age 34. One from IT where the age is 36. One from marketing where the age is 41. And one from IT where the age is 31. Okay. The next one, select employees who are not in the HR department and make more than 50,000. So if you remember what we just looked at, I said we have a not equals operator, which looks like this here. And so to check that someone is not in the HR department, that is what you would do. And so let's borrow from here and I'll start this off. Okay. So we're going to say where department does not equal, and then HR, and they also need to make more than 50,000. And so like we used or here, there is also an and. And so I think you should be able to figure out how to do this having done that last one. So I encourage you to pause me now and give this a go. Okay, so we're saying we want all employees where the department is not HR and so here what we want to do to check that the salary is greater than 50,000 is we use the greater sign, semicolon on the end. Let's run this. Okay, so looking at the departments, none of these are HR, so that has worked. Looking at the salary, all of these are greater than 50,000. Okay, now this next one is interesting. It's saying find employees whose name starts with A. And so it's going to start much the same. So select star from employees. And then we're filtering on name, so we can guess that we're going to need where name. And then instead of using equals or greater than or anything like that, we use something called the like clause, followed by, so we know it starts with A, and then we can use the percentage sign to represent other characters or any remaining characters. So this is going to find us all employees whose name starts with A. Okay, semicolon on the end there, hit go. And so it looks like there's only one, and that is Alice Johnson. Let's go and check that. So over to employees, and if we look down the list, we can see there is only one, and that is Alice Johnson in marketing. Okay, so I think I'll let you have a go at this, and one which you can have a guess at actually. So what we're going to do here, this might be quite fun. You've seen how to find employees whose names start with A. How about employees whose name ends with an N? How do you think you might do that? This is what we did to find records that start with A. How would you modify that to find records which end with N? Pause me now and have a go at that. Okay, so here's the solution. Again, we're finding all employees and we're selecting all columns where name, again, we're going to use the like, but this time we want all the characters before that, but it must end with an N. So we've reversed the percent sign. We've put the percent sign first and we've put the N last to show that it's ending in an N. Let's select all of these, fire that off. And as you can see, we've got 3 records, 3 names which end in an N. So if you gave that a go and you got it correct, well done. And even if you didn't get it correct, well done for having a go at it. It does become quite intuitive. After you've started writing your first few queries and figuring things out, it becomes a lot more intuitive. And especially if you're having a go, I'd always recommend having a go at these because they're only small little practices, aren't they? Alright, select employees whose age is between 25 and 35. A little clue here if you want to work ahead. There is a between keyword which looks like that. So how do you think using that keyword we could find all employees whose age is between 25 and 35? So I'm going to write this one out in full. Select star from employees where, and we're going for age, and then we're going to say between 25 and 35, just like that. So it reads pretty much just like English. Select star from employees where age between 25 and 35. Let's select that. Okay, and so here we have 6 records. Let's check the ages. They all look to be between 25 and 35 to me. So that is how you select all the employees where the age is between 25 and 35. Okay, so I think that's been a pretty good introduction to select queries and a lot of the things that you can do to select and filter. We've selected for just particular columns, and then we've filtered on all different kinds of things. We've put in little ors in there where we can say choose this or that, or we've put ands in there where we say this condition needs to be met and this condition also needs to be met. We've used some negation. And we've also used like, which you can use to find records which match a particular pattern. And here we said we wanted all records which begin with an A, so we use the A followed by the percent. I think you called it a wildcard, but you might call it something else. Let's not get bogged down in names. What it means is it represents any remaining characters. And so here what it does, where we say we want employees whose name ends with N, we're saying that the percent sign represents any preceding characters and ends with an N. And then we also looked at between, where we say between this being 25 and that being 35. Okay, good. So what we're going to have a look at now is we've touched on primary keys previously, but we're now going to have a look at a bit of a recap on primary keys, but also have a look at having multiple tables and joining those tables using foreign keys, i.e. a key on one table which references a particular column on another table. What we've just worked through there is a small sample from the full course, just to introduce you to SQL and MySQL and also queries, and also to introduce you to the teaching style of the course. If you've enjoyed working through it and you're making progress and you want to continue, then you can enroll in the full course, and I'll leave a link down in the description.